So this lesson is not required by the curriculum, but it is good enrichment, and we have the time, so we are going to look at this lesson. So if you look at the note at the top of the page, it says, to be eligible to vote in Canada, you have to meet the requirements. You have to be a Canadian citizen, you have to be at least 18 years of age, and you have to be on the list of electors. So assume that for this lesson, that when the phrase Canadian citizen 18 years of age or older is used, the person's name is on the list of electors. So we have these conditional statements. A conditional statement is a statement that we use, it's an if-then statement. The hypothesis is your if, the conclusion is your then. So if a Canadian citizen is 18 years of age or older, then the person is able to vote. If a person lives in Victoria, then the person must have been born in BC. So which of these two statements is true? Or are they both true? So if a Canadian citizen is 18 years of age or older, then the person is able to vote. Is that true?
True.
Yes. If a person lives in Victoria, then is the person born in BC?
No.
No. Okay? So if-then statements do not necessarily have to be true statements. They could be false. A conditional statement has a converse, which also may or may not be true. So it occurs when we interchange the hypothesis and the conclusion. If a Canadian citizen is able to vote, then the person is 18 years of age or older. True or false? So if you can vote, does that mean you're 18?
Yes.
Yes. Okay? If a person is born in BC, then the person lives in Victoria. No, that is false. So the converse statement does not necessarily have to be true or does not have to be true either. So we're going to write a conditional statement. An acute angled triangle has three angles that are each less than 90 degrees. So we are going to write this as an if-then statement. So we make the first part of the statement our if, and the second part of our statement would be then. So if an acute angled triangle, if a triangle is acute angle, other way around. If a triangle is acute angled, then it has three angles that are each less than 90. So now if I write the converse of it, the converse means just switch them around. So instead of starting with if a triangle is acute angle, start with the second statement. If a triangle has three angles that are each less than 90 degrees, then what?
What is K?
What is what? Less.
Oh.
L-E-S-S.
It's like,
Sorry. So if a triangle has three angles that are each less than 90 degrees, then what? So you grab the first statement. Then it is acute angle. If a number is divisible by 4, then it is an even number. So give me numbers that are divisible by 4. 8, 12, 16, all of those 20, 24, 28, etc. If I write the converse of this statement, what would the converse converse of this statement be? So flip the F and the N, then.
If a number is even, then it's divisible by 4.
Okay, so if a number is even, then it is divisible by 4. Is that true or false?
That's false.
Give me a number that's even that's not divisible by 4.
6.
6. 6 is an even number, but it's not divisible by 4. So there's an example of a conditional statement in which the converse is not true, but the original statement was. So that brings us into biconditional statements. If I have a statement in which the original statement and the converse statement are both true, then I have a biconditional statement. So in that first one, a Canadian citizen is allowed to vote, or sorry, if a Canadian citizen is allowed to vote, then the citizen is at least 18 years of age. If a Canadian citizen is 18 years of age, then they are allowed to vote. Both of those statements were true. So I could rewrite the statement saying a Canadian citizen is allowed to vote if and only if the person is at least 18 years of age or older. So I replace my if-then with an if and only if statement. So if I look at class example number 4, if a triangle is obtuse angle, then the triangle has one angle between 90 degrees and 180 degrees. Is that true or false? What's an obtuse angle?
Oh, it's true.
An obtuse angle is more than 90 degrees, less than 180. In a triangle, if I have one of those angles being obtuse, can I have two angles that are more than 90 degrees? No. Because if I had, let's say this one was 100 degrees. Okay? What is the sum of these two angles have to be?
40.
80.
80. So 40, if you're thinking being 40 each,
Yeah.
but it has to be no more than 80 because the sum of the angles in a triangle is
180.
180. So I can't have more than 80 degrees, which is less than 90. So these two angles cannot be obtuse. So if I go the other way, if a triangle has one angle between 90 and 180 degrees, then the triangle has to be obtuse. Is that true? So if I have an angle between 90 and 180, does this make this an obtuse triangle?
Yes.
Yes. So then I can write this as an if and only if statement. A triangle is obtuse angled if and only if it has one angle between 90 degrees and 180 degrees. Then we have contrapositive statements. So the contrapositive of a conditional statement is formed by taking the converse and then negating both the hypothesis and the conclusion of the converse. So, start off with your conditional statement. If a Canadian citizen is 18 years of age or older, then the person is able to vote. The contrapositive would be if a Canadian citizen is able to vote, then the person is 18 years of age or older. The converse is reversing the conditional. The contrapositive, now we negate it. If a Canadian citizen is not able to vote, then the person is not 18 years of age or older. So let's work on this example. Here's my conditional statement. If a triangle is obtuse angle, then the triangle has one angle between 90 degrees and 180 degrees. So if I write the converse of that, what would the converse look like?
If the triangle has one angle between 90 degrees and 180 degrees, the triangle is obtuse.
Yes. So if a triangle has one angle between 90 degrees and 180 degrees, then it is obtuse angle. So the contrapositive says take this statement and insert the word not. So if I negate this statement, what would the statement then be?
If the triangle is not obtuse angle, then the triangle does not have an angle between 90 and 180 degrees.
Keep it the same form though. If a triangle does not have one angle between 90 and 180 degrees, then it is not obtuse angle. Okay, so we leave it in the same form as the converse. We just start sticking in those knots. So if a triangle does not have one angle between 90 and 180 degrees, then it is not obtuse angled. Okay, so now we're going to put some of this stuff together. Consider the following if-then proposition. If z being a number, is greater than 2, then z squared is greater than 4. Is this true or false? So if it's false, you'd be able to give me an example of a number that's greater than 2 that when I square it is not greater than 4.
This statement's true.
Okay? Okay, so then let's write the converse. What would the converse be? So the converse, take the if and then and switch them places. So if what?
If z squared is greater than 4, then z, it would be greater than 2.
That's my statement. Okay? Is this true? Or can you give me an example of when I take z squared and I square it, I get a number that's greater than 4, but z itself is not greater than 2?
No, this statement is true. Oh, never mind.
Is this true or false? If I take negative 3 and square it, is that number greater than 4? So what's negative 3 squared?
9.
9. Is 9 greater than 4?
Yes.
Yes. But is negative 3 greater than 2?
No.
No. So this makes the statement false. Okay, so now let's write the contrapositive. So the contrapositive puts negatives in it. So if z squared is not greater than 4, that's how I'd write not, then z is not greater than 2. So if z squared is not greater than 4, it means that it has to be what?
Less than 4.
Less than 4. But if I'm squaring a number, do I get negatives when I square a number? If I take a number and multiply it by itself, is it possible to get a negative number? No. So the most that I can have is I can go from 0 to 4. Okay? So suppose z squared was 1. How do I get 1? 1 times what? 1. So 1 squared is not greater than 4, and 1 is not greater than 2. If I chose negative 1, what's negative 1 squared? Positive 1, which is not greater than 4, and negative 1 is not greater than 2. So is the contrapositive true or false?
True.
I've proven it true twice.
Oh, true.
I haven't found a counterexample. And I know that if I square this number, I'm always going to get a number that's somewhere between 0 and 4. Okay. Last example. If Peter lives in Saskatchewan, then Peter lives in Regina. True or false?
False.
And why is the statement false?
So you can live anywhere in Saskatchewan.
Because you could live anywhere in Saskatchewan. Okay, so then let's write the converse. What would the converse be? If Peter lives where?
Regina.
In Regina. Then he lives in Saskatchewan. Is that true or false?
True.
That's true. Okay. So it's true. Okay, so let's write the contrapositive. So if Peter, what would the contrapositive say?
If Peter lives in Saskatchewan, he lives in Regina.
No, that's the conditional statement. That's
the
just
not.
reverse. That's the adding the not. So if Peter does not live in Regina, then he does not live in Saskatchewan. Is that true or false?
That is false.
False. If he doesn't live in Regina, could he live somewhere else and still be in Saskatchewan? Yes. Okay. So there is a general rule that states if the conditional statement is true, so that was with class example number 6, the conditional statement was true, the contrapositive is true. If the conditional is false, the contrapositive would then also be false. So it's just something good to know so that when you're going through these, if you know that one is true, then the other one has to be true. Okay? It does not mean that if the conditional statement is true, the converse is false. Because sometimes the converse statement can also be true. It means that the conditional and the contrapositive are the same. Okay? So, the questions for you to practice with. Questions 1, 2, and 5, doing A, D, and G of each. So it's writing the conditional statement, then writing the converse, and then writing the contrapositive. And it's the same statement. And then question number 9.